Inverse functions. When we have a conversation about inverse functions does not mean we're looking at reciprocals. It is not the same as reciprocals. Inverse functions has a different notation. We're going to say f inverse of x. It puts a little -1 on the f. It's not an exponent. It's just a notation to say that this is f inverse of x. So that means we're not going to work with that -1. We're not going to plug that -1 into a calculator. What it is saying is if we were to have a function such as f of a equal to b, so we have some kind of situation, then the inverse would be that f inverse of b would be equal to a. So what the inverse functions are doing are they are switching the domain and range. And so we are taking all of the x's and switching them with all of the y's. So your original equation, domain and ranges, when it switches to the inverse, the domain becomes your range becomes your domain. In a very simple example, and we're going to do lots in this inverse functions area, if you had f of 2 equal to 4, and you want it to find the inverse, that means the inverse of 4 would be equal to 2. So you can see 2 was in the x, but now it's become the y. 4 was in the y, and now it's become the x when we move into this inverse. And so what I want to do is kind of slowly work through this. I want to first work with some tables, and then I want to give you a process on how to create inverse functions and work at an equation. And so first, let's look at the example of a table. When you're looking at this table, say it said, what is f of 1? Well, we've already worked with tables before. When you look at f of 1, 1 is your x value, and so that means f of 1 would be equal to 0. Well, another way of looking at that, and you've seen this with function notation, is what if it said, what is f of x equal to 2? What is x? And so you would say, okay, f of x equals 2. That means that 2 is your y value. So you'd look on your f of x column all the way down to 2 and say, okay, well, what is that x value? That's paired with 5. And you've done that before. That's function notation. We're just reading the table and pulling values. Now, let's look at this and look at it from an inverse perspective. If it said f with a tiny little -1 of 9, that reads as the f inverse of 9. Remember, up here in our example, these were our x values and y values. So when we go inverting them, these are y values, these are x values. So I'm going to look at this and say, okay, f inverse of 9, that means this is a y value. So this means f of x is equal to 9. So you go to your f of x table and go down to wherever you find 9. And what is that value? That is 8. So you kind of have to switch your mindset when you're reading a table. We'll do another one. What is f inverse of x equal to 5? Now they are going to switch up their variables, and they're going to call it x, because you can see up here in our definition, we were talking about f inverse of x. But in relation to the original function, that was a y value in the original function, and this was an x value. So this means, what is f of 5? If we look at it from the function side of it, the f of x side of it. So I'm going to go where I find an x value of 5, and that links to 2. So that means f inverse of x equal to 5, then x equals 2. And it can be kind of confusing maybe to read it on a table that only has your x and f of x values. So if need be, you could rewrite and you could create a table just for f inverse. Remember when we just said that the x values of your original become your f of x inverse values? So let's just recreate that. So we're going to list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then earlier, these were y values, but now they become your x values when you're looking at the inverse function. So 5, 0, 1, 7, 8, 2, 6, 3, 9, 4. So let's maybe approach this again, and let's look at what we did before. What is f inverse of 9? If you create your own inverse table, that might be easier for you because then you could go to 9 and go up. It's paired with 8, which we saw that here. And what is f inverse of x equal to 5? Well, here is f inverse of x, just like it's asking. So I'm going to look down here and find 5. What is the x value? I could just revert that over to 2. So you can look at f of x and inverses in a table either by looking at the original table by itself or create you an f inverse table. And maybe when we were over here, this table made a lot more sense, but you could see all we did was switch those x's and y's. So just take a couple seconds, rewrite your f inverse table, and then go from there. Now let's go down and let's look at working with equations. When we're working with an equation, I just want to kind of get our feet wet with how to work with the table so we can see how x's and y's are just replacing each other, especially like we saw in that last part of that table. But I don't want to create a table for every single value when working on an equation. I want to be able to create an equation for the inverse so I can quickly go to that. And so here is going to be our steps for that process. Step number 1, you want to replace f of x with y. It's going to make our life a little bit easier just to use the y instead of the function notation. Step number 2, you're going to switch x and y. So it's a literal rewrite everywhere you have an x of a y, a rewrite of everywhere y you have an x. We're going to work examples and use these steps. So I want to get our steps over here to the side so we can kind of work through those in the process. Step number 3, you're going to solve for y. Number 4, you want to replace y with f inverse of x. And then step number 5, restrict the domain if necessary. So that's going to be our 5 steps as we work through this. And really looking at it, the bulk of your work is going to be in step number 3. Okay, so that's really going to be the algebraic process of step number 3, but we're going to keep the other 4 steps to assist us in this process. So step number 1, we need to replace f of x with y. So now I'm going to say y is equal to 2 over x minus 3 plus 4. So all I did was change it to y. Step number 2 says to switch x and y. So instead of y to start with, I'm going to say x. I'm going to keep everything else the same. And then instead of x minus 3, I'm going to say y minus 3. Step number 3, solve for y. And so what I want to do is I want to get this y completely by itself. And so first thing I'm going to do is I'm going to subtract this 4 over. So it gives me x minus 4 equal to 2 over y minus 3. Now it's really causing me a problem to have that y in that denominator, having the 2 divide it by the y minus 3. So I'm going to multiply both sides by y minus 3 to get that out of the denominator. It had division, so if I multiply, that will cancel. Those are inverse operations of each other. On the left side, I have y minus 3 times x minus 4 equal to 2. Now, at least I don't have a fraction. I've got this y right here. Well, I really need to get rid of that x minus 4. Well, instead of multiplying, we're going to see the reverse. I'm going to divide both sides by x minus 4. So that gives me y minus 3 equal to 2 over x minus 4. We did create a new fraction, but that's okay. We're not going to freak out about it. Our goal is to get this y by itself. So last step, I'm going to add a big 3 to both sides. So that lands me at y is equal to, put it down here, y is equal to 2 over x minus 4 plus 3. So I told you, step 3 is going to be the bulk of what you do. Now, number 4 said replace y with f of x. So step number 4, I'm going to now call this f inverse. Keep with my colors here. This is the only thing I'm changing. F inverse of x is equal to 2 over x minus 4 plus 3. And so that would be my inverse function for for the original f of x of 2 over x minus 3 plus 4. Now, step number 5, we need to restrict the domain if necessary. Now, we know because this is a fraction, we can't have 0 in the denominator. So over here to the side for step number 5, I need to say x minus 4 cannot equal 0. So x cannot be 4. So that would be the only domain restriction that I would need to make in this process. So now some of this does get a little complicated. I know fractions can kind of freak people out, but just kind of take it step by step as you go. Let's do this next example. It says to find the inverse of f of x. So we're going to follow those 5 steps from above. First, we're going to replace f of x with y. So step 1, I'm going to say y is equal to 5 minus x over 3x plus 2. Step number 2, I'm going to switch x and y. So it gives me x equal to 5 minus y all over 3y plus 2. Step number 3, solve for y. And that's really the bulk of where your work is going to come from. So in this case, I've got to get both of these y's completely by themselves. Or really, I need to be able to move all pieces that have a y over. So this is going to be a little bit more complicated, but we're in college. We can do this. Okay, so I am first going to do like I did in that previous example, and I'm going to multiply to get rid of that fraction. So I'm going to multiply both sides by that denominator. So it gives me 3y plus 2 times x equal to 5 minus y, because this would cancel. Now, I am going to move that x over, but before I do that, I'm going to go ahead and distribute because I think that'll be easier for me. That gives me 3xy when I distribute that out, plus 2x equal to 5 minus y. And you can see I still have a y here and here. So I want to move all the pieces that have a y over to one side and everything that doesn't have a y onto the other side. And so I'm going to say, okay, well, let's add this y over here. So it gives me 3xy plus y plus 2x equal to 5. I can't combine it with anything because it's just a single y. This one has an x on it. Then I'm going to subtract 2x. So it gives me 3xy plus y equal to 5 minus 2x. Now that I have everything that has a y over here to this side, I'm going to factor a y out. So that gives me y times 3x plus 1. What I'm doing is just kind of undistributing that. I do need a 1 as a placeholder because I removed everything, equal to 5 minus 2x. And then now I finally have a singular y. So that's y times that grouping. So I'm going to divide both sides by 3x plus 1 to get rid of that grouping. So I get y equal to 5 minus 2x over 3x plus 1. Told you, step 3, it can be a doozy. Step number 4, I would say f inverse of x is equal to 5 minus 2x over 3x plus 1. And then step 5, restrict your domain if necessary. I have a 3x plus 1 in the denominator. My denominator can never equal 0. So 3x plus 1 cannot equal 0, and then I'm going to solve that out. So let's see, that gives me x cannot equal negative 1/3. So that means all other numbers are going to work except for negative 1/3. Now, don't drop my class. Don't quit. It was a little bit harder process on these two. Let's do another example, and it has a little bit less complicated issues going on with the inverse. Here's the next one. It says find the inverse of f of x equal to the cube root of x plus 4. Again, I'm going to keep numbering my steps so you can follow along. Step number 1, rewrite with y. Don't change anything else, rewrite with y. Step number 2, switch x and y. So I just rewrite the problem with my x's and y's in each other's spots. Step number 3, solve for your new y. And so I'm going to say, okay, well, to get rid of that cube, the cubic root, I'm going to have to cube both sides. So it gives me x cubed equal to y plus 4, because these would cancel. Those are inverse of each other. And then I'm going to subtract 4. So it gives me x cubed minus 4 equal to y. See, step number 3 in this one wasn't as long. Step number 4, rewrite with f inverse of x instead of y. And now in this one, there is no step 5 because the domain of this is just all real numbers, or negative infinity to infinity. So there's no issues with this. I don't have a square root. Square root is where you have some issues. And I don't have division, so I don't have to worry about a fraction or something not equal to 0. Now, a lot of the practice that you're going to do is creating the different equations or inverses. And so you want to make sure you just kind of follow your 5 steps, go slow, be meticulous with your details. You can do this. The last thing I want to show you on how inverses are kind of paired and go with things is it's going to revert back to what you know about composition. So how do I test if 2 equations are inverses of each other? So here's where we get this statement. It says, if f composed with g of x, you're going to have to do a composition, is equal to x, and g composed with f of x is equal to x, then f of x and g of x are inverses. And so this gives us a way to test if 2 equations are inverses of each other. In practicing with compositions, you always don't get the same result. But in this case, if you get the same result of both of these being a singular x, not a 3x, a singular x, not an x squared, a singular x, then you're going to have inverses. So I want to do a quick 2 examples with you on this. It says, are f of x and gx inverses of each other? So you need to first check, is f of x equal to gx? And what is g of f of x? So you're going to have to do some compositions. So my tips for compositions is your first letter is going to be your template. Your second letter is going to be your plugin. So let's execute that. F is going to be your template. So I'm going to have 1 over something plus 2. G is going to be your plug-in. So this is my G equation. I'm going to say 1 over x minus 2. This is why you always need to be able to clean this up so we can actually see if it gives us that x that we want. So x minus 2 and plus 2 are going to cancel each other. So it's going to give me 1 over x. And then you're going to keep change flip, or you're going to say 1 multiplied by flip that over. You can see that gives me an x. Now this was an and statement. G of f of x also has to be x to see if this is an inverse. So we're going to do this again, same process. This is going to be your template. This is going to be your plugin. And so my template is G. And so I'm going to say 1 over something minus 2. My plugin is f. So I'm going to say 1 over x plus 2. Now with this one, you can't just mark out those 2's because those are tiny little 2. So the first thing you have to do is you have to set up this division. So that's going to be 1 divided by 1 over x plus 2 minus big 2. So I'm going to say keep change flip whenever you are dividing fractions. You keep the first fraction, change it to multiplication, and flip the second minus big 2. So this grouping here just gives me x plus 2 minus 2. So now I can cancel those 2's and it gives me an x. So it says, are f of x and g of x is inverses of each other? Yes. Now, if it's a yes or no, the work that would need to be shown with this is that check, I got x, check, I got x. Anytime you're working any problems in math, you have to support your answer, and you do that by showing work. So this is not just yes, no, you have to prove why it's yes, and you do that by composing them in both directions. Let's do one more example. It says f of x is equal to x cubed and g of x is equal to 1/3 x. It says, are f of x and g of x is inverses of each other? So we can't just say yes or no. We have to prove it. We have to say, what is f of g of x and what is g of f of x? And so again, F is going to be our template. So we're going to have something cubed. What is that something going to be? It's going to be your G equation. So 1/3 X. Since there's no addition or subtraction here, you just distribute that cubed. So it gives me 1/3 cubed, X cubed, which gives me 1/27 X cubed. Now, that is not a singular X. So already I can tell you, no, these are not going to be inverses. But for inverse sake, let me show you how the other one works out. So G is your template, so that means you're going to have 1/3 times something. That something you're going to plug in is an X cubed. Now cleaning that up, that gives you 1/3 X cubed. So not only are these not singular X's, they're not even the same. So even furthermore of why these are not inverses. Again, make sure you're showing all your work, and any of this process, just having an answer is not going to give you full credit. If you need additional help, please reach out to your instructor.